Hello, welcome to our workshop Possibilities in Resistance and Biofumigation. I am Michaela Schlathoelter from PH Peterson in Germany. That is a private, independent seed and breeding company, and I'm a breeder. We are located in Germany, and we are specialists for breeding nematode resistance in cover crop. We breed also other fodder crops and some other crops. And my colleague?
My name is Matthias Landgraff, working as product development manager in AgroTip. And we are also German-based vegetable seed company. We have over 50 years of experience in the industry, and here from Germany, we organize our breeding work mostly in the US and Europe, and also our seed production, which is done in worldwide in the most suitable places. And yeah, our sales is organized via a dealer and distribution system in over 50 countries worldwide.
We will tell you something about possibilities in resistance and biofumigation. Growing a green manure crop should improve yield and quality of the main crop. Otherwise, a farmer wouldn't spend the work and the money for a cover crop. This is done at first by the basic points, by increasing the soil fertility, by adding organic matter, by promoting useful soil organisms, by promoting soil structure, keeping nutrients, improving water holding capacity, and by erosion control. But there's also an effect of reduction of diseases by being a non-host or a host for special diseases, and thus having an influence on health and disease of the following main crop. The third way is the biofumigation, and that will be told later on by Matthias. I will start with diseases. In the database of Best4Soil, you can evaluate which possible trouble a crop makes with different diseases or nematodes. But cover crops has to be handled also as a member of the system and have an influence on disease control by growing time, by behavior toward disease, whether it is reducing or multiplicating the disease, and by the growing technique. My target is to improve resistance in cover crops so that you have a strong tool for soil and plant health. There are several nematodes which may cause problems in your main crop. Resistance we find very good in radish. For example, beet-cyst nematodes, which cause problems in sugar beets and other crucifers. And normal radish variety have a multiplication about 5 to 7-fold in a crop rotation or in a growing season. If you use a special bred variety, you have the possibility to reduce your nematode population up to 95% just in the season of growing a cover crop. This biological control is by limiting the production of females just before they divide into males and females. Another resistance mechanism we can select for in radish is the resistance against root knot nematodes, Meilleures, which is a really strong disease in many main crops. Normal radish varieties here give a good basic. They are poor host for this nematode, but we select variety which are controlling root knot nematodes like fallow. But they have the advantage that they add additional organic matter to the soil and thus help the following crop. This resistance mechanism is by reduction the rate of females, the reproduction rate. So you find small galls, but you do not find any reproductive eggs or larvae. We try to combine protection in multi-resistant variety. So we can find this, or we select for cyst-forming nematodes, for gall nematodes, but also against Ditulenchus, which is a stem nematode, against Bratulenchus, and against Trichodorus and the Tabak-Rettel virus. We can find resistant types. Additional, we look for some fungi diseases like Rhizoctonia, Fusarium, and also clubroot is possible to control with radish. One example is the multi-resistant radish contra, controls during the growing period nematode and disease as described. So he controls Heterodra schachtii, Melodogine, Bratulenchus, and Ditulenchus, and has also an effect on Tabak-Rettel virus, Trichodoriden, and Rhizoctonia and Fusarium. Matthias will tell you now about the additional possibilities with biofumigation besides the growing period.
All right, biofumigation can be understood somehow as an advancement of the normal cover crop. It adds a technology and a value to the normal green manure, and for the biofumigation we take benefit of a biochemical reaction, and this chemical reaction is part of the plant-own defense mechanism. It's something that's existing in the nature and we just take benefit of it. Within this reaction there's a gas that's released from the plant, and we can now force this hydrolysis, this reaction, for our own purpose. The target organisms are usually soil-borne fungal and bacterial pathogens. The main actors in biofumigation are glucosinolate and myrosinase, which is an enzyme, and they are natural ingredients of the plant, of the brassica plants, of many different brassica species. Usually these two compounds are well separated in a living, healthy plant, well separated from each other. Once the glucosinolate and the enzyme myrosinase get in contact in the presence of water, they produce a gas which is the isothiocyanate. And this isothiocyanate is toxic to many microorganisms, whereas we have to tell it suppresses many plant pathogens, but it spares most beneficial microorganisms. So we can summarize: bad for the bad organism, good for the good organisms. To illustrate what's happened on the plant cell level, we have here a sketch of a plant cell, and you see within the vacuole you have the glucosinolate, and outside the vacuole you have these red dots, which illustrates the myrosinase. They are both well separated by the vacuole membrane. Once the plant cell gets disrupted, the glucosinolate and myrosinase get in contact, the hydrolysis starts more or less immediately and releases the gas. As you can already tell, the higher the glucosinolate content, the more ITC you get out of the reaction. Efficiency is therefore limited to the glucosinolate and or myrosinase content. Most species that are used or are possible to use for biofumigation have either a very high content of glucosinolate or a high content of myrosinase. For example, Xenapis alba is known for its high myrosinase content, but the Brassica juncea is known for its high glucosinolate content and also for the glucosinolate profile. Using a blend combines the advantages of both worlds and increases your ITC yield, if you will. Biofumigation in practice starts, like with any other crop, you need to prepare a fine seed bed. But already with the fertilization, you can optimize your biofumigation a lot. Always do it based on soil analysis, and you should end up with maximum 50 kilogram nitrogen per hectare. Better you anticipate 30 to 40, that's enough. If you exceed, you can have a dilutive effect on the glucosinolate content, and therefore a limited effect, or you're limiting the effect of the biofumigation. If you need to apply fertilizer, you should choose sulfur-containing fertilizer, because sulfur plays a central role in the glucosinolate content. Sowing rates as a general guideline is 30 kilogram per hectare for the oil radish and 15 kilogram for the Brassica juncea or Xenapis alba due to the seed size. And then we are coming to a point which makes the difference between a normal cover crop green manure and the biofumigation. We call it the harvest, but you don't take anything away from the field. You leave everything on the field. You start with a chopping or mulching of the plant. And this should be done as fine as possible, meaning you have a low speed of the tractor and a high rotation on the rototiller, or mulcher, whatever you're using. Incorporating in the soil should be done as quickly as possible due to the ITC being volatile. And also the hydrolysis starts immediately, and you want to keep the ITC in the soil. Flat roll the soil, seals it to a certain extent, and you make sure that the concentration can increase within the soil. Soil moisture is required for the biofumigation. It helps also to increase the concentration of ITCs in the soil, and you really should avoid to incorporate into a dry soil. Some examples of how it looks in practice. This is a mulcher and front mounting, and you see it's very fine chopped, very small pieces of the plant. In the back, you have the rototiller for direct incorporation, and right after the rototiller, you have rolls to compress and seal the soil. This is the ideal version for biofumigation, chopping, and incorporation. But of course, not always these possibilities are available. You need to find a solution for your farm, and this is just another example. The perfect timing for biofumigation as a guideline depends a little bit on what you're doing, what you're anticipating. The biofumigation, which is mostly done with a Brassica blend, the best timing is at full blooming, because at this point you have the highest glucosinate content within the plant development cycle. Be aware if you have nematodes in the soil, because if you're anticipating nematodes with your biofumigation or multi-resistant oil radish, you need to know, you need mandatory to incorporate the biofumigation crop 6 to maximum 8 weeks after sowing, despite of any flowering. After 8 weeks, the risk of building up a next generation of nematodes is rising significantly. After chopping and incorporating, you should wait 10 to 14 days to plant or sow the main crop. We told a lot about advantages, and we don't want to glorify too much, because there are still challenges and limits and points you should take into consideration for biofumigation. For example, the effect on specific pathogens. On nematodes, you can have a really good effect of 80, 90, 95% even for some nematode species, but some fungal or bacterial pathogens, you hardly observe such a breakdown effect, but you always generate a very good long-term effect. Glucosinolate contents varies during the plant growth. Again, as a guideline, at full blooming for the biofumigation is a good moment for the chopping and incorporation. all plant cells contain the glucosinolate. And this is the challenge and the big potential that we have. Also, this is why we are recommending to go with low speed and high rotation to disrupt as much cells as possible to explore most of the potential that you have. The hydrolysis, this is a challenge, starts immediately. Therefore, and also because the ITC is volatile, the concentration in the soil can be insufficient if you don't incorporate immediately. Another point that should be taken into consideration is that the target organism have a different sensitivity to the isothiocyanate. For example, the various tight structures of Sclerotia or Ralstonia solani, you can hardly observe a very good breakdown effect in the first year. But by weakening the pathogen and supporting the soil fertility, the microorganism in the soil, you weaken the pathogen and support the beneficial organisms over a long period of time. And by incorporating the biofumigation into your crop rotation, you have a very good long-term effect. And we must say this effect is very, very sustainable because it remains, even though we don't apply biofumigation after a couple of years of application. To come back to how we started initially, you take benefit of all the positive aspects of the normal cover crop. You can steer soil pests and especially nematodes by selecting the right varieties. And as an added value, as a topping of all this, you have the biofumigation effect to suppress specific fungal and bacterial pathogens. Well, thank you very much for your attention. I hope you learn a lot today. Yeah, and we remain at your disposal for further questions.